Swayam Prabha. Digital India. Educated India.
Hello, welcome to this third lecture of Module 10 on engineering geological facets of natural hazards and mitigation, landslide, earthquake and induced seismicity. In previous lectures we have discussed about landslide, different features of landslide, about mitigations, causes of landslide, and in these lectures we are going to elaborate about slope stability aspect, forces acting on landslide or slope, calculation purpose and approaches. In this we are going to discuss about the slope stability aspects of landslide. Regarding this we are going to cover about types of failure and slope stability aspects of landslide, then the forces operating on slope, and then approaches, concept of factor of safety and support measures in form of rating. Friends, we have already elaborated about classification of landslide. Based on failure planes or the geometry of failure planes, we are able to divide the landslide in four categories, namely planar slide, circular slide, wedge slide and toppling slide. The planar slide, circular slide, wedge slide, you can see a view of planar slide. Circular slide, if you are going to check this section, it becomes circular in shape like this, and then wedge slide and then toppling type of slides, you have idea. So the slope can be divided as a soft material slope based on the material, and the slope in hard rock strata, where the hard rock strata is going to show this four type of failure mode: planar, circular, wedge and toppling. In type of failure, the planar failure takes place along the prevalent and continuous joint dipping toward the slope with strike nearly parallel to plus minus 15 degree to the slope, and stability condition occurs if critical joint dip is less than the slope angle and mobilized joint shear strength is not enough to assure stability. If this slope, this is the slope and this discontinuity line, then we are going to see about the failure of this block on this planar failure. Generally a planar failure depends on the joint continuity. However, the wedge type of failure, the wedge failure occurs along two joints of different sets when these two joints strike obliquely across the slope face and their line of intersection delights in the slope face. You can see one view. This joint set 1, joint set 2 and then joint face, if we are going to interact these planes, then there is a formation of wedge type of slide. The wedge failure depends on joint altitude and conditions and more frequent than the planar type of failure, because in nature we are having more than one set of discontinuities and that going to show the detachment of rocks and slide. Therefore in nature we are getting wedge type of failure more in comparison to the planar failure. In addition to this, we have circular failure. Circular failure dominated in highly fractured rock or in soft material. In case of rock strata, it is dominated in highly fractured rock mass or highly fractured ground, where this strata is started behaving like soil. And toppling failure, as we already discussed, considered a block of rock resting on inclined plane, and in layered rock and in the layered and traverse rock we are having toppling failure. Some of the examples we have here: a slope failure is following a simple concept, as we have already discussed in class 8 to 10 in simple mathematics. When a block is resting on an inclined plane having some inclination, the block may be slide down, or block may be roll down, or block may be roll down and slide. This concept developed by the Hook and Bray in 1991, and I have taken source from this. You can see about this changes in condition. If we are here, see a block is resting on inclined plane having the weight directly downwards W. W can divided in two components: normal to the surface W cos psi and W sin psi toward the down dip, and this W sin psi is responsible for dragging this block with having height h and width b. If the angle between this inclined plane on which this block is resting is a phi, then we can see the ratio of this b plus h along with the base plane angle phi degree. You can see the phi degree is bearing from 0, 10, 20, 30, 40, 50, 60, 70, 80 and 90 degree up to vertically. We are going to drag this up to 90 degree. Then what will happen on the block resting on inclined surface? Very simple. The ratio of b to h, width into height, width by height, 1, 2, 3, 4, 5. You can see this region where this angle psi is ranging below the 40 and b plus h ratio is in range covering in this domain. We are getting stable blocks because this base angle is less. However, with increase in base friction, if this block is going to move up, means making more angle, more than this 30 to 50, 60. In such situation where this phi angle between this base of plane and the angle of internal friction phi, if the psi is greater than phi, means base plane angle psi is greater than frictional angle and b by h is more than tan phi, then in such case the block starts sliding from its position toward the downward. However, in case of this block having angle up to 35 degree, but the b plus h ratio is very less, in such cases this block is started rotating here, turning down, toppling down, and only toppling type of movements we are going to get. However, the considerable value of the b by h, where the psi is more than phi but b by h is less than tan phi, tangent of angle of internal friction, then in such condition the blocks started sliding and toppling simultaneously. This concept given and published by Hook and Bray in 1991 in his. So in this way we can see when this block is showing slide, when this block is showing toppling, when this block is showing slide and toppling both, and when this block is in stable condition based on the angle representing the angle with B and H, and representing angle of friction, and representing the base plane angle. Here the region we have already discussed about region 1, region 2, region 3, region 4. In this way, when the block is sliding and toppling, when the block is here, this P is representing phi. Revealing slopes, falls, accumulation of scree or small pieces of rocks, which we have already discussed, have detached from the rock mass at the base of steep slopes, and the cyclic expansion and contraction associated with freezing and thawing, going to result formation of cracks, fissures and others, and formation of rock mass in form of blocks. The rock mass are the principal reason for the slope revealing, and a gradual deterioration of the material which cement the individual rock block together may also play a part in this type of failure. And weathering of the rock strata is causing deterioration of certain type of rocks on exposure, and will also give rise to the loosening of rock mass and accelerating the slide. As far as effect of height and groundwater is a concern on the stability of slope, these both parameters is going to influence about the slope stability, which are leading to landslide. Particularly the slopes consisting of rock strata various researches have carried out on various types of work involving analytical technique, numerical method, analog modeling and equivalent modeling, different approaches, but still we are facing lot of problem due to landslide throughout the world. And in such directions, we have one important rating approach based on rock mass rating system or rock mass quality categorization. Manuel Romna in 1985 has proposed one excellent type of rating system recognized as slope mass rating system. The slope mass rating system was nothing. It was based on basic rock mass rating system proposed by Wieniawski in 1979. RMR system initially had 6 parameters, but the basic have 5 parameters, including the rating for uniaxial compressive strength, rating for RQD, rock quality designation. The rock quality designation proposed by Deere et al. In very early, and then next parameter is rating from joint spacing, rating from joint condition, rating from groundwater, etc. In this way, the Romna has categorized different type of slope by using some adjustment factors. So the slope mass rating in rock mass classification scheme developed by Romna Sahab in 1985 to describe the strength of an individual rock outcrop exposed in a slope. Friends, we know that the slope is made up of soil as a soft slope or made up of rock strata as a hard slope. In case of soft slope, this concept is not applicable because this concept is required to consider slope comprised of rock strata and rock mass. SMR is developed as modification of rock mass rating system proposed by Beniavsky in 1979, and it is an approach to assess the engineering geological behavior of rock slopes in view of rock mass characterization. This slope mass rating, short name SMR, is nothing is equal to RMR basic minus F1 into F2 into F3 plus F4, where the F1, F2, F3 are adjustment factor, mainly depends on the joint dips and the strike of slopes and the nature of slopes. However, the fourth component F4 referred for the method of excavation. So F1, F2, F3 related to the joint slope relationship. However, this F4 is related to excavation technique. The RMR basic, we know that it is a rating for UCS plus rating for RQD plus rating for joint spacing, rating for joint condition, and rating for groundwater. This all component after summation, then we are going to subtract the multiple of F1, F2, F3 for adjusting the slopes, and then going to add F4. In this way we are going to calculate slope mass rating very correctly and very easy way. Friends, you can see here the joint, dip and slope. In this we are going to consider here the strike of joint, and this is the main joint. Here beta S we are representing from the surface, and the joint dip from the slope we are considering this. Another slope beta J we are considering here. So in this type of consideration, the adjustment factor is actually representing F1 based on parallelism between joints and slope of face strike, and F2 you can see this strike of the face of slope. F1 values varies from 0.15 to 1, where 0.1 is referred for the angle between the joint plane and the slope face strike more than 30 degree, and failure probability is very low. But when the value of F1 is 1, both are close to parallel, and later on this F1 concept, earlier it was utilized as a general consideration to give the value between 0.15 and 1. Later on this F1 people have started calculating by F1 is equal to 1 minus sin A whole square, where the A is angle between the joint planes and slope face strike. This joint plane and slope face strike. F2 is the joint dip angle in planar failure. F2 values ranges from 0.1 to 1.0, same as we have observed in case of this F1 also, and this way value we are going to recognize in case of F2. 0.15 dip of joint if the less than 20 degree, and 1 if the joint dip is more than 45 degree. For toppling failure it is not applicable, and we are considering for toppling failure F2 is 1.0 as a value. Later on people have started calculating F2 is equal to tan square B, where B is the joint dip angle. F3 representing the relationship between the slope face and the joint dip, and the value ranges not described properly, but in some cases it is ranged from 0 to minus 60. These F1, F2, F3 along with these measurements, sometimes with respect to dip, with respect to strike between this joint plane and this slope face, etc. Then we are going to add this F2. F2 is referred method of excavation. If it is natural in condition, then the value is given as plus 15, and if involve normal blasting, it is considered as F4 is 0, because controlled blasting as per SMR concept given by Romna, he has considered that the controlled blasting is not going to damage any slope strata, not going to affect the strength of rock strata. In case of natural slope, the erosion and deterioration of strata and others, weathering, although in general going to influence the strength of rock strata, but as per Romana concept of SMR, he has considered that the natural slope is not going to experience about the effect of erosion or weathering or any type of deteriorations. Therefore, feeble type of deterioration, therefore we are going to consider plus 15. But the blasting, mechanical excavation are not going to damage the slope, therefore F4 is a 0. So natural causes, Romana has considered erosion, weathering as effective, shallowly effective, therefore value is less. But here normal blasting excavation methods is a completely not under consideration, and given a 4 value is 0. Further, later on in advances in this direction related to excavation method, the peoples referred as a modification in the slope mass rating, and F4 considered for the natural slope as plus 15, but pre-splitting condition plus 10, smooth blasting plus 8, and blasting are mechanical 0, but the deficient blasting is a minus 8, going to strengthen, going to subtract, not going to add. So natural slope affected by erosion, weathering having the value plus 15, in case of going to support or enhance the SMR value, because these process as per Romna going to clear and make the slope resistant. Blasting and excavation is not going to modify anything as per earlier convention, but smooth blasting and others also going to enhance, not going to damage anything, and pre-splitting blasting also. If we are going to see about support measures based on the slope mass rating, so 65 to 100 based on calculation, none, and simply scaling required. Scaling required means we are going to take one rod and going to make the cleaning of the face of excavated zone or slope if required. SMR value 30 to 75 recommended bolting and anchoring to stabilize any slope which is made up of rock mass and having value 30 to 75. However, slope mass rating ranging between 20 to 60 requires shotcrete protection and placing of concrete in such kind of slope where the rock mass is showing SMR value 20 to 60. The SMR value, not SME, SMR value is 10 to 30 is problematic and required wall erection and re-excavation for modification of slope and wall erection for protective wall to protect the such type of area having this value. And limitation, this approach is not effective in case of wedge failure, and for determination of the wedge failure induced instability or landslide, we require to modify this concept. This concept was only applicable for the planar type of failure. For circular failure located in high fracture rock also, this approach is not more effective, as the highly fractured rock is going to behave close to soil slope, and this SMR concept is only applicable in case of the rock strata, not in case of soil. As far as forces operating on slope is a concern, very simple, the weight of material that going to make the rock strata or weight of the rock mass or soil is important, that going to act downward following the gravitational law. This diagram I have taken from the site. And the rock, soil, vegetation and man-made structure which act downwards is going to load the slope, and this next force is the shear force acting tangentially and balanced by frictional force. Shear strength of these material acting on potential slip which resist sliding in form of frictional force are the shear resistance. Simple way, if we are going to see here weight of block, this weight of block can be resolved in two components. Simple way, W sin beta if the beta is angle with respect to horizontal, and normal to this potential failure surface is here n is a normal, and the opposite of this is the W cos beta. The shear resistance we are considering following the Hooke's law and the Mohr-Coulomb's concept, C plus W cos beta tan phi, where phi is angle of internal friction. In this way we can see if this W sin beta is greater than this frictional resistance sigma Fr, then the shear resistance is not able to restore its position and this whole mass is going to slide down quickly. Next type of concept is safety factor, and friends, safety factor is an operational research terminology widely utilized in field of engineering, any branch of engineering starting from mechanical engineering up to petroleum, civil and others. The safety factor ensures the stability of slopes or the stability of any engineering operations. It depends on the ratio of resistance force, shear strain to the driving force. It is the safety factor in generalized way is a concept representing the relationship between resisting force and disturbing force in any work, particularly related to the slope engineering or slope stability concept. We are working with the different forces acting on a mass which are likely to be slide down. In this, safety factor is defined as resistance force divided by driving force. In this we can see the resistance force is the shear resistance. Shear resistance you can calculate, that is the frictional resistance. So this frictional resistance divided by driving force, you can see this downward acting W sin alpha or beta. So that component W sin beta, where the sigma fr is the represents about the interaction of the C cohesive strength and the area of the contact, then cos beta and the tan phi angle of internal friction for translational type of slides, where this mass is going to slide on the potentially failure surface. If the water is present, then water is going to influence and going to reduce this shearing resistance and going to accelerate the movement of this mass, are going to enhance the chances for the slide. So only here we are going to W cos beta minus simply minus U and then tan phi. This normal, this represent normal stress, and in normal stress we are going to reduce about the pressure caused by water. So if the water present here, it can push this zone up on one side, on another side going to lubricate this contact and going to make this frictional resistance less. If frictional resistance less, an upward acting force due to water, in such situation the down dragging force toward the down become more effective, and in saturated condition this mass is going to slide. Friends, in rainy seasons we are observing number of slides due to saturation of slopes. Therefore, the mountainous peoples are more conscious about the rainy season, because the saturated slopes are more prone to slides due to reduced frictional resistance, enhance upward acting force, which are going to upthrust this zone, and the effective resultant force is working toward the downwards, going to accelerate. If this rotational type whole mass is going to rotate like ball, then in such situation this criteria, the shear resistance is not having the business with this area but have business with this length. So therefore, in place of A we are going to multiply this L, CL plus W cos beta tan phi by this mass M sin beta for rotational slide. If saturated, then we are going to here add like this, CL plus W cos beta minus due to water sigma W or mu, and in this way then tan phi by M sin beta. So in this way we are going to simply analyze this. We have different approaches. In brief, I try to explain quickly. We have deterministic method, which are going to determine the condition of slope by considering planar failure. Based on very simple concept, a block is resting on a inclined plane. Under water effect or under dry effects, you can see one view. The slope is arranging, this upper face is arranging this angle, and this angle, the water saturation is going to push this, which we have already discussed, and this water field here is going to detach this zone. So the stability, if we are going to calculate this volume of this per unit, then we can see what is the value of this mass W, what is this work, what is the effect of this U, and what is the resistance here. And in this way we are able to calculate. You can try this calculation. Is a simple way. Another method is kinematic analysis. Kinematic analysis is very simple. It is going to use the dip and strike of the joints along with the slope phase and going to plot in stereo diagrams where this block is this type of formation of block due to intersection of different poles, going to indicate about the stability aspects. Friends, these materials I have prepared from the paper written by Romna M in 1885, published in form of paper, New Adjustment Rating for Application of Benioff Classification to Slopes. For initially it was presented in 1985 in International Symposium on Role of Rock Mechanics, and in between page 49 to 53. Then partial support I have taken from the paper written by Hook and Bray in 1991, published online in www.researchgate.net with this reference. Then partial supports from the paper written by Gupta, Pradeep Gupta and the Anbalagan R, and partial supports from these books as Engineering Geology book and textbook of Engineering Geology. Friends, as we have already discussed, the potential failure surface is of planar type, circular type, wedge type and toppling type, and the SMR is an approach based on the RMR basic and adjustment factors, where the F1, F2, F3 we are going to subtract and F4 we are going to add. F1, F2, F3 representing about the adjustment factor, where the F4 is representing about the excavation method. The major forces acting on slope is a gravitational force, water force, and time to time we are experiencing also seismic force during earthquake. The factor of safety is the ratio of resisting force and disturbing force acting on a slope, and the major approaches for estimation of slope instability are stability or deterministic, kinematic and analyticals. Dear friends, thank you. In these lectures we have elaborated about the slope stability aspect. Dear friends, in this class we have elaborated about the slope stability aspects of landslide. In this we have elaborated about different rating system and then approaches in brief, then concept of forces acting on slope. Thank you for your patience.